Hello GCC, welcome back. We're working on some Lewis dot structures. We did 3 of the structures. We have 1 more to go on this slide, and it's the hardest one, CO2. So C's in the middle with 2 O's around it. Now you could have done it left to right, up, down, left to top. It doesn't really matter, but I drew them on either side, left to right. So I have my O, C, O in a straight line. And the Lewis dot structure ended up needing double bonds. So single bonds didn't work. Let's start out by adding up our valence electrons. Carbon has 4 plus oxygen has 6, and there's 2 of them. So 6 times 2 is 12, plus the 4 makes 16. So we need 16 electrons in our drawing. If you tried single bonds, you didn't have 16 electrons. It didn't work. So then you double. Don't do both doubles. Try one double. So C double bond O and then a C single bond O. So a double and a single bond. But that didn't work either. But sometimes it might, so don't skip that step. But it didn't work for CO2. So we had to try both double bonds. And we need to make everyone happy. Let's look at the drawing up here with my cursor. The carbon in the middle has 2 double bonds on either side. Double bonds are 4 electrons. 4 here and 4 in the other double bond make 8 total, so carbon is happy with 8. Now let's look at one of the oxygens. It has a double bond, so that's 4 electrons. So it needs 4 more, so we do 4 dots or 2 lone pairs. And then oxygen has 8 around it. It's happy. The other oxygen is the same. It needed 4 dots or 2 lone pairs, and it is now happy. So once again, we have a happy structure, but is it 16 electrons? Let's look at the structure, look at my cursor, follow along and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, 16 electrons. So the double-double combination worked for CO2. That is the structure. All right, so now we've seen many Lewis dot structures. I hope you're getting the hang of this. We're now going to do Lewis dot structures for polyatomic ions. Everything's the same, but they are going to have a charge because it's an ion. Polyatomic means more than one atom with a charge, ion. If the polyatomic ion is negatively charged, that means it gains some electrons, so we have to add them in. If the polyatomic ion has a positive charge, that means some electrons went away, so they're gone, so we need to subtract them. We're going to put brackets around the whole thing with the charge in the upper right corner. Let's try NH4+. So we have a group of atoms, more than one atom, polyatomic, but it has a +1 charge, so it's an ion, NH4+. Now I didn't underline anything. Can hydrogen be in the middle? No, hydrogen can't be in the middle. So nitrogen's in the middle, and we have 4 hydrogens to put around it. So 1 on each side. Something like this. Yeah. Okay, now let's make everybody happy. Hydrogen needs to have 2 electrons around it, and it does because of the bond. There's 2 electrons in the bond. So hydrogen has 2 electrons around it, so it's happy. All the hydrogens are the same. They're all happy. Nitrogen needs 8. Look around the nitrogen in the picture. Look at my cursor. Nitrogen has 4 bonds around it. There's 2 electrons in a bond. So 2, 4, 6, 8. There are 8 electrons around the nitrogen, so it's happy. So everybody's happy. Now, valence electrons. Let's add them up because we should have done that first. Nitrogen is 5. Hydrogen is 4 because there's 1 each and there's 4 of them for 4 total. So that's 9, but we have a plus charge. If we are positive, That means a negative electron went away. So we subtract 1. 9 minus 1 is 8. 8 valence electrons should be in our picture. Let's look. In our picture, we have no dots. We have 4 single bonds. They are 2 each, so 2, 4, 6, 8 electrons in the picture total. So that's a match, 8 and 8. So we're done. It was single bonds. It worked out. We put brackets around the polyatomic ion, and the +1 charge goes in the upper right corner. All right, that is the Lewis dot structure for a polyatomic ion NH4+. Now I want you to try these 3 yourself. Hit pause and give a try for BrO3 -1, SO4 2-, CN 1-. All right, do your best. All right, we're back. Let's look at these ions. BrO3-. Single bonds worked. So BrO3- looks like that. Single bonds. Put it in brackets with a -1 charge. Okay, if you're not getting these, you need to message your instructor and get a little time with them in office hours or a Zoom session, okay, to practice some more. Let's move on to SO4 2-. S is in the middle. We have 4 oxygens around the S. Single bonds worked for this one. And we put it in brackets with a -2 charge in the upper right corner. Everybody has 8. Everybody's happy. And then the last one, CN-. There's no middle because it's just 2 atoms. So just CN. Draw a line in between them and go. Well, a single bond didn't work. A double bond didn't work. Yeah, CN- needs a triple bond to work. And there's a lone pair on the C and a lone pair on the N. Put it in brackets, put that -1 charge out to the side. All right. So that's how you do polyatomic ion Lewis dot structures. So I hope you did a good job on those. Again, at this point, if you're not getting the Lewis dot structures, I would talk to your instructor and try to set up a one-on-one session with them. All right, next topic is the shapes table. So I asked you to print this out at the beginning of the chapter. So go grab that when you're ready to watch the next video. Thanks, GCC.